for you to pay attention to instructions. And the reason why I'm very strict with instructions is I know that all of you are going to some healthcare, And do you know that if you don't follow instructions, a patient can die?
Right.
Yeah, not reading, not following. And I know that firsthand because I had a patient die under my care because my nurse didn't follow the instructions, gave the patient the wrong dose. And even if I wrote there, be sure to ask the patient. My writing, I think, is very nice. Make sure the patient had nothing to eat for 8 hours. Forgot to ask the patient. The patient was a very young guy. He was, I think, 19 years old. He came, I was rotating in the neurology ward. He came for his last treatment for neurological. It was his last. And he died. Why? My nurse forgot. He didn't ask that very important question. And this is why I really want you guys to, I know it's just a test, but I'm trying to make you learn to follow instructions. But don't worry, don't stress out too much. I will try as much as possible to help everyone. Stress is not good, right, Robert? Stress raises your blood sugar, so you're going to be a diabetic. So don't do that, okay? Just relax. And if you work hard, you're going to do well. So today we start with our special senses. I think we're just going to do, what do you call this? Our taste and smell today, okay? So special senses. The reason it's called special senses, I don't have The reason it's called special senses is because, do you remember the shape of the neuron? What's her name? Batten. Okay. It's the bipolar. You remember the bipolar neurons? Remember multipolar, unipolar, anaxonic? The bipolar neurons, those are special sense neurons. Wow, this is nice. Okay. What was that? And also, it's special sense because the receptors are all localized in the head. So that's why we call them they're also part of your nervous system. It's just that they're so important. They're just, especially vision, right? It's very important for us to see something before we can process any information, okay? And so we're going to talk about your smell. You should know olfaction means smell, right? Your olfactory nerve. Vision for sight, hearing, equilibrium. And then taste, gustation. You know that? So let's look at, by the way, as far as stimuli, you should know that olfaction is a chemical stimulus. So what gates are being opened? Your chemical gates, right? Same with gustation, it's a chemical sense. So chemoreceptors, okay? So here, this is photoreceptors. For hearing and equilibrium, mechanoreceptors. And you will see why. So first, let's look at our sense of smell, our olfaction. Where is this? Where is this sense of smell found? Where?
Our nose.
Are you sure? Are you sure it's in your nose? It's in your nose, you're right. Like right here. Right? Look, when you that's why when you want to smell, there's a faint smell. What do? Because it's right up there. There's your nose. It goes all the way up there. So this area right here, what's this bone? This is your ethmoid, remember? Ethmoid bone. So this area right here is where you will find what you call your olfactory epithelium. And right here in the olfactory epithelium, you have the nerve endings. So these are the chemoreceptors that monitor your the chemicals. So this, by the way, all chemicals that stimulate our olfactory receptors are called olfactants, odorants. That's why you use a deodorant, right? Odorants. So they're called odorants. These are the chemicals that we sniff, odorants. So if you forgot your deodorant, your odorants will be smelled by your lover. Okay? Okay. So there's your nose. You see, look at it's there's a reason for this conky. I don't know if you remember. Remember in your skeleton you call them the conky, superior, middle, and inferior conky. There's a purpose for this conky. It slows down the air when you sniff it, or when you every time you inhale, it creates a turbulence. So that turbulence helps in the mixing of the chemicals so that your receptors can be stimulated and you can report to your what lobe of the brain? Temporal lobe, right? It can go to the temporal lobe. So you become conscious of that smell, okay? So, and it also, do you know that in your let's look at this epithelium, this olfactory epithelium. So they have a magnified view of the olfactory epithelium. Look at the cells that make up your olfactory epithelium. I see my neuron, right? My olfactory receptor cell, which is what type of receptor? Chemoreceptor. These are chemoreceptors, right? And also there are supporting cells, and there are stem cells right there. So you have your basal cells. They are the stem cells that's able to regenerate and replace the injured receptor cells. Olfaction and smell are unique to your nervous system because we have studied that neurons do not regenerate. However, here in your nose and for taste, you have stem cells already, right? This really will not regenerate. But we have stem cells there. They're just waiting to become your replacement. And it makes sense because epithelium, right, it's constantly exposed. Whereas all the other neurons, they're hidden. But this one, they have an exposed surface. Does it make sense? Okay? And then there's this important gland, B, Bowman's gland, B for boogers. That's why we have boogers and we have to pick our noses. So this one secretes mucus. And that mucus, so your nose is always moist. And don't you think that moistness will create what do you call it, like a quicksand, or it slows the chemicals over there, right? So then it gives your receptors enough time to be depolarized, generate action potential so you can smell. Okay? So let's see the physiology of olfaction. How do we smell? So this one, you see, there is your olfactory bulb. That's the one that's attached to your cerebrum, right? So this one synapses, and then it goes to what lobe of the brain? Temporal lobe. So that is the pathway for smell. So the olfactory tract from your receptors, right, all the way to the temporal lobe. You need to remember that in addition, so when it gets to the temporal lobe, we become aware, right? But in addition to the temporal lobe, so this is the primary pathway. The olfaction also, they send collaterals to your limbic lobe. What's your limbic lobe?
Your memory.
Memory, right? So that's why when the book, I think this tells about when you go home and you open the door and you smell apple pie or chocolate cake, chocolate chip cookies is I think what they used. You remember when you were a child, brings back memory. because of that collateral to your limbic lobe. And it reminds me of when I was just dating my Baba, right? Because I told you I would always, spray so he will remember, brings back memories. So that's the same what he did. He would also spray so that when he's gone, I will remember him. So you smile, you just, all this, sometimes you laugh to yourself when and it's because of your memory, okay? So don't forget that, because I think I like to ask that in the test, your last test on your olfactory system, okay? Olfactory sensation. So that's it about smelling. Very easy. Huh? Next, we're going to go, look at, this is amazing. Every time I read this, we look at, you have 10 to 100 million receptors in the olfactory epithelium. But what's that dog, the greyhound? They have way more receptors. Their receptors are in the... Yeah,
Greyhound's the one that runs. The tracker is the basset.
Oh, what? The hounds.
The hound is the hound.
They said they have in the billions. And I think that's why they're the ones being used to detect for drugs in the airport, right? Because their sense of smell is unbelievable. So, okay. So the next sensation. So don't forget that collateral to the limbic lobe. There's also a collateral to your hypothalamus. So your smell, sense, and of course you remember always the cerebellum, right? Cerebellum is very nosy. Okay. Next is your taste or gustation. So, again, chemoreceptors, right? So, your taste receptors are located in what you call taste buds. Taste buds. And the taste buds are spread all over. You think you have, of course we know, not you think, but we know we have taste buds in our tongue, right? But we have taste buds all around also in our cheek, the roof of our mouth, right? Even all the way to the pharynx or the throat, you have taste buds there. So where are these taste buds located? So let's say this is me, this is my nose, my eyes, right? There's my mouth. And then there's my tongue, okay? Okay, so your taste buds are actually under. Okay? So right there. You see that? So there's my taste bud over there. You see the picture? It's nice, right? There's the taste bud. So look. So you see the taste bud is under, right there, okay? And it has to be, it's not right there on the surface, because then that means every time you drink or eat something hot, gonna injure it, right? And you're maybe eating something very sour or spicy. If they're right on top or on the surface, you will injure it immediately. So they're all the way in the recesses of our tongue. They are located within what you call lingual papilla. Oh, papilla. Okay? And you have different type of papilla. So you have the circumvallate papilla, this one in the back here. When you go home or when you go to the bathroom, open your mouth, you say, you stick out your tongue. And you see this different papilla, right? Right here. Right there, right? That is your circumvallate papilla, making an inverted V. And then you have your fungiform papilla, which is the most abundant. It's mushroom shaped. There is also what you call a filiform papilla. The filiform papilla, write down in your notes, the filiform papilla, this one here, they have nothing to do with taste. This one. What do you use a nail file for? Use a nail file when there's something rough, right? So the filiform papilla creates a rough edge to your mouth. so that the food, it promotes friction. So the food is, you're able to chew. So the tongue helps in keeping the food in your oral cavity so that it's not slippery. So they create a roughness to
Is
your
that what
tongue.
gives cats that really, really rough tongue?
Yes.
Like
Does it
sandpaper?
make sense? Okay. So in your tongue, in your cat, you can feel that filiform papilla over there. Okay. So this is the only one that has no taste buds. You see, I don't see any taste buds. But the others will have those taste buds. And let's look at this taste bud. So the taste bud, just like your olfactory epithelium, I have my receptor cells, the gustatory, so those are my receptor cells. Then again, I have my supporting cells. It's always supported because it's exposed. It's basically epithelium, isn't it? And then you have your stem cells again because they are constantly exposed, right? So they are chemoreceptors. And how do we taste? Oh, by the way, what is the cranial nerve? I forgot. The cranial nerve for smelling. Cranial nerve number? So yes. So this one, synapses with cranial, these are the beginnings of your cranial nerve number 1, your olfactory nerve. But for taste, look, for taste, there are 3 cranial nerves. And in my past tests, I had a picture of the tongue like this, I think. And I would always ask, what are the 3 cranial nerves that function in taste? And using a pencil or using arrows, please point to the area where they monitor taste sensation. So the 3 cranial nerves are 7, 9, and 10. So facial, glossopharyngeal, and your vagus nerve. And look at, they have their own area of coverage. So 7 is the anterior 2/3 of the tongue. Cranial nerve number 9 is the posterior 1/3. And then cranial nerve number 10 is in the pharynx. You see? That's why you can taste water. Isn't there taste for water? And you taste water as you swallow it. So your taste for water is right there in the back. What are the different taste sensations, by the way? Salty, sweet, sour, bitter, and then there's the umami flavor from the MSG that Chinese, they use that for seasoning. That's the savory, meaty flavor. So those are the different sensations monitored by these 3 cranial nerves. So these 3 cranial nerves, in addition to monitoring taste sensation, they are also very important for saliva production. So if you have problems with taste, automatic you think 7, 9, and 10. I'm thinking. And then how do you differentiate? So then you ask the patient to smile, right? That will help you rule out cranial nerve number 7. Then how about for glossopharyngeal? The gag, right? And then the vagus, you ask the patient to open the mouth while say, you look for that uvula, or look for if the patient is able to say, that means the voice box is working, cranial nerve 10 is okay. All of them, all these 3 cranial nerves, what will be the common symptom? Loss of taste or ageusia. Have you heard of this one, ageusia? Loss of taste. Agnosia, loss of smell. Loss of taste. Then all of them also will have decreased saliva, dry mouth. All of them. The 3 of them. It's common because they both secrete, are responsible for secretion of saliva. The facial nerve, saliva from your sublingual gland, you don't need to worry. That's too much. Okay? Okay? So where is it going to go? Taste goes to what cranial, what lobe? What lobe? Taste. Parietal lobe and insula. Okay? Taste goes to your parietal lobe right here. Parietal and the insula. And look at, there are again collaterals to your limbic and your hypothalamus. Just like me, I refuse to drink milk because every time I drink milk, I remember that day when I was young when my mother hit me in the head because I don't want to drink the milk. So I refuse. When I drink that, I just brings back. I'm sure you have memories like that, right? Like some people have an aversion for eggs. You don't like egg. Then brings, maybe you broke up with your boyfriend. That's why you don't like eggs now. Maybe something like that, okay? Or something like that. Okay? So, very easy for taste and smell. Now we go to the eyes. This is your next special sense. This is your eye. So I think on Monday is the day that we will open up your eyeballs. You get to look at your eyeballs. That's the last day. And so then on Monday you have everything. You have your muscles, you have your brains, and you have your eyeballs to study and prepare for your last lab exam. Okay? So here is the eye. It's called the dominant sense in humans, right? Because they say majority of our sensation is influenced by vision. That's why I think if you become blind, when you used to be able to see and you become blind, it just, you become also depressed because you're used to seeing, right? Okay, so here's your eyeball right here. So that's the eyeball. This is the one that's responsible for vision. So in this eyeball, that's where we find receptors, the photoreceptors. But this is so fragile, we know that, and it's so important that it is protected by a lot of accessory structures. Okay? So the eyelids are what we call the palpebra. You familiar with that palpebra? So there's your superior palpebra, the upper eyelid over here, and this is the inferior palpebra. Okay? And then under that one, under the palpebra, you have conjunctiva, right? Then you have hairs right here. These are your eyelashes. These are your eyebrows. Do they have a function? Yes, right? What's the function of your eyebrows? That kind of what? Yes. Yeah, in case there are cockroaches, they can't move forward. Right, you have lots of germs. This, wherever there's hair, remember there's acidic pH, and we know we have bacteria. Some people, they like to use makeup that is forever in their drawer maybe, and they said, I don't know if it's true, they said some makeup, that's where there's lots of bacteria, and we put it all over like that, right? So this one at least prevents bacteria from trying to infect our eyes, okay? And then sweat, we sweat. So that creates like a shade, right? Prevent your eyeballs from the sweat. And some books, they say it's like an umbrella for your eyes, okay? And the palpebra, by the way, this one, the palpebra, it's very important to close because we have tears there. The blinking helps in spreading the tears, keeps your eye moist. And that moistness is very important for refraction. We're going to see how we see vision, refraction, and then vision. We're going to trace that to the brain, okay? So there are two things, have you ever seen some people with stye? You know what stye is, right? So stye is infection right there in the eyelashes, so they have a redness right there. What's pink eye? So there's the stye. So sometimes your problem is in your conjunctiva, you have pink eye. And there's another one called chalazion. So under your palpebra, you have seen some people with like a mass, but it's like in there, not on the eyelids, but there's like a redness, but it's like inside the flesh of the eyelid. That's what you call a chalazion, okay? Because under your palpebra, you also have glands there. And the glands, if they get infected, they call it a chalazion. They're both the same. They're both infected glands. they just use the term sty. When you see sty, automatic you know it's in the eyelids, so eyelashes region. When chalazion, you see the word chalazion, automatic you know it's under the conjunctiva. It's both infection of the glands. The last accessory organs that help in the function of, not the last. The second to the last are tears. So your lacrimal apparatus. Tears are very important, right? Tears help in trying to flush away any debris in our eyes. Our eyes also have cells there, and so metabolism always produces waste products there. So they need to throw their waste products in the trash. So the tears serve as a trash pick-upper. Okay? So that's what they do. Look at how tears, where the tear, you have your lacrimal glands located on the superior upper part of the lateral part over here of your eyeballs. So just by gravity, so the gland makes the tears, and by gravity it falls down, right, to flush your eyes, and then it drains again by gravity through these canals out to your nose. You see? And so every time you blow your nose, or the moistness there, some of that comes from your eyes, your tears also. Look at, very important, in wherever there is a secretion, any secretion, not urine, but wherever there's a secretion, there's always this lysozyme, which is, what are lysozymes? They are powerful antibacterial enzymes, right? So when they are part of your eye or your tears, don't you think that would be protective, right? And there's antibodies there too, immunoglobulin A, which you're going to appreciate when you take up Bio 242. You're almost done. So the formation of tears is actually a parasympathetic function. So increased parasympathetic activity will promote increased production of tears. Then the last accessory organs that help the eyeball, help us see. All of these help us see, okay? You have your extrinsic eye muscles. These are skeletal muscles, okay? And what they do, they move the eyeball. So if they're skeletal muscles, that means they can be, what do you call this? Voluntarily controlled. So here are your muscles: lateral rectus, medial rectus, superior, inferior rectus. Rectus means erect, right, straight. So lateral, medial. So they help me look right, left, and then erect, and then the oblique. Very easy, right? So just so there's only two cranial nerves, three, 4, and 6, but most of them. So if you remember LR6, SO4, everything else is innervated by cranial nerve 6. So sulfate, SO4, right, and then LR6, lactated Brenner solution that you. So LR6, SO4, and everything else is innervated by cranial nerve number 3. So if there's any injury, you see, you remember how you test. So your trochlear nerve, that helps you look down. The eyeballs are being focused obliquely to this pen, and then you look down. So it is tested by your trochlear. It's testing your trochlear nerves. Okay? Next. So finally, we go to the eyeball itself. Here it is. And I think to study the eyeball, I'm going to take out one eyeball now, so that on Monday, you do your own eyeballs. Come to this table over here. We're going to open up one eyeball. Can we take that out? Thank you.
Don't worry. Just broke a heart.
Oh yeah, thanks. Thank you very much.
Little gush.
I know. I don't know why I tried that. It didn't go obviously together, but whatever.